Okay, so one last graph, and this time I mean to throw everything at it. We've got changes in the amplitude. We've got changes in the period. We've got a phase shift, and we've got a shift upward by 1. So what are we going to do? Well, here's the way that I always handle it. My laundry list of material contains the following. I always identify my amplitude. In this case, the amplitude is positive 2. And since there's not a negative in front of this sine function, we're going to keep it at that. Our period, the period of the function, is going to be 2 pi divided by b. We've got 2 pi divided by 4. In this case, that means our period, one full period, will be completed within a cycle of pi over 2 units. Key points. I always put key points at 1/4 of the period apart. So we're going to take 1/4 times pi over 2. That's going to give me pi over 8. Pi over 8 is the increment of how far apart each of the key points will be from one another. But then we also have a phase shift, and our phase shift is found by setting the argument of the sine function equal to 0 and solving for x. So I'm going to take 4x minus pi over 4, and I'm going to set that equal to 0 and find out what happens. Well, in this case, 4x equals pi over 4, meaning that my phase shift, x, is going to be pi over 16. And this means it's going to go to the right because we've got the subtraction right here. Our starting value on our x-axis for one cycle will be at pi over 16. Now, the only other thing to know right here is that there's going to be a vertical shift upward of 1. So what does that mean for our y values? Well, in this case, if we treat 1 as a center axis, our range is going to change. Our domain, by the way, is going to remain as negative infinity to positive infinity, but our range is going to be found by taking this vertical shift minus the amplitude, and taking that vertical shift and adding the amplitude. So our range is going to be from -1 all the way up to +3 along the y-axis. And again, the domain will be all real numbers. Now, we're only going to show one cycle of this graph, so that's all we're concerned with. So to graph this function, as far as the x values are concerned, I'm going to add increments of pi over 8. Now, the nice thing about pi over 8 and pi over 16 is that pi over 8 only needs to be multiplied by 2 in the numerator and denominator to get the right increment. So we can think to ourselves, if we don't reduce anything, these are increments of 2 pi over 16. So taking increments of 2 pi over 16 instead of pi over 8, pi over 16 plus 2 more pi over 16 is going to give us 3 pi over 16 as our next key point. Adding 2 pi over 16 again is going to be 5 pi over 16. Adding 2 pi over 16 is going to give us 7 pi over 16. And one more time, so we have a total of 5 key points within the cycle. That's going to be 7 plus 2, 9 pi over 16 within one cycle. As far as the y values are concerned, since this is a sine function, normally the sine function is going to start on the center axis, go up to its maximum point, come down to the center axis, go down to its minimum point, then come back to the axis. Well, in this case, normally where we might say 0, 1, 0, -1, and 0, imagine multiplying each of these values by 2 for the amplitude. So 0 times 2 gives us 0, 1 times 2, 0 times 2, -1 times 2, 0 times 2, and then add the vertical shift. So add 1 to everything, and our y values are going to be found at 1, for the first key point, 3 for the second key point, 1 for the next key point, -1 after that, and then our final key point within that one cycle will be at +1 again. So graphing, here's how this will look. I'm going to use every other line as a vertical distance of 1. So this is the line x equals 1 as my center. My amplitude is 2, so I'm going to go up 1, 2 above that here to +3. I'm going to go 1, 2 below that to -1 as my lower amplitude value. So going along this very lightly dashed up line here, above and below the center axis, this is going to give us a reasonably good picture. Our y values, our x values along the x-axis right here, we started at pi/16 as our first key point, a shift to the right. Our next key point at 3 pi/16. The next one at 5 pi/16. The next at 7 pi/16. And the last at 9 pi/16 within one full cycle of the graph. Since it's a sine function, it started at the center axis, so pi/16, 1. 3 pi/16 goes up to its upper amplitude value, which is 3. 5 pi/16 comes down to the center axis. 7 pi/16 goes down to -1. 9 pi/16 back to that center axis. And so graphing this function for one full cycle, we're going to come up kind of like this in that one cycle. We're going to go down to our lower amplitude band, and then we would begin that cycle over again. And here is one full cycle of the graph of y equals 2 sine of 4x minus pi/4 plus 1.